So now we are going to see the Ansys Fluent tutorial. For consider a rectangular channel or pipe. Okay. So the left hand side is inlet, the right hand side is outlet, top and bottom is the wall. Okay. So the 2 centimeter height and 10 centimeter length. Okay. So the inlet velocity is 0.1 meter per second. So if you are applying 0.1 meter per second, your diagram should be you draw in meter, or if you are using the velocity input converted into centimeter. Okay, then atmospheric pressure, you know the values, atmospheric pressure we can apply. Okay, then we can go to Ansys workbench. Just you can click on the Ansys workbench. This is actually a 17.1 version. Okay, so once you click on the Ansys workbench, you can have a screen like this. In the left hand side, you can see now design assessment, eigenvalue buckling analysis, explicit dynamics, fluid flow, blow molding, like that, fluid flow CFX. So we can go to the fluid flow Fluent. Okay, the option you can go to fluid flow Fluent. Then here in the right hand side you can have a project box will come. The project box, the bottom you can change the name. Okay, bottom you can change the name like this. Then you can go to the option view files and properties. So then it will show the properties. Okay, by clipping the properties, so just you can it will show where you are going to save the files. Okay, so the file whatever file you are having, where it is saved, that information it shows. Then you can go to set analysis type, go to geometry. First you define the geometry. Okay, first click on the geometry, then it will, the next screen will open. You can select the analysis type, 2D or 3D. Okay, 2D analysis you can go. Then you can click right side, the geometry, right hand side. If you click new geometry, new desktop modeler geometry, you can go. Then it will show the screen. Okay, then it will show the Ansys design modeler. It will open automatically. Then you can select that there is a plane is there, XY plane, YZ plane, ZX planes. You can select the XY plane. Okay, then after XY plane you go to the new sketch. Okay, select the sketch mode. Okay, then select the pick the point, the axis. Then you go to the sketching option. Once you go to sketching option, there are many drawing tool is coming. Line, tangent line, line by 2 tangents, polyline, rectangle, like this. By using this command, you can able to draw different type of sketching. 2D sketching means you can draw this. If you are having any 3D modeling, okay, immediately you can after drawing the 2D, you can go to modeling. There is a lot of options are there. Then you can create the modeling. Okay, so this Ansys workbench itself, you can able to create a lot of models, complicated models also you can able to create. So these drawing tools, and you have a modification tools are there. You draw a rectangle, then you can go to constraint. So constraint means just we can use the coincide. There are many constraints are there, fixed, horizontal, vertical. Okay, symmetry options, parallel means. So you just give the constraint like this, coincident. So, okay. So two edges you can select automatically, the edge will be coincide. Then you can go to dimension, general, and select the height and length of the rectangular section and give the value. Then what happened now, the model will be create as per your dimension. After creating the model, 2D lines, you have to create the surface, 2D surface you have to create, that is called plane. Okay, so where you have to go now, you can go to the same design modeler, concept is there. Okay, in the concept, sketch from surface from sketches. So this is very, very important. So you just select the edges, 4 edges, you select pins. What happened now, automatically, so the sketch, so surface from sketches, then you can go to this base object, or you can directly go to the rectangular line. You select the 4 lines, automatically the surface will come by picking the generate command. Okay, by picking the generate command. So this is the needed for all the 2D model. Okay, anything, any boundary, anything, after drawing the boundary, okay, then you have to create the surface. Okay, suppose if you are modeling like a wind tunnel section, that is you are keeping the aerofoil inside or any object inside, circular, flow over the circular, flow over the square, or flow over the triangle. So anything you can create in the center portion. Okay, so center portion you can draw one more rectangular section. Then you can use the surface option, you can pick the 2 edges, automatically in the center portion there is hollow. Okay, center portion is not filled. Okay, so your object is not filled, remaining your fluid medium only you have to create the surface. Okay, so this is about modeling creations or 2D sketching. Then you can go to meshing option in the first front screen. Okay, in the Fluent screen. So Ansys workbench, you can go back, and that is a project, whatever the laminar project you have said, no, that laminar project you can go. Then you can go to mesh, right hand side edit, then you can go to the edit option, then it will automatically shows meshing. Okay, the left hand side you can able to see surface body, and the bottom you have meshing. So now if you click the surface body, the thickness is coming 0, and what type of fluid you can able to give, select the fluid option. Then you can go to meshing, you just click the meshing, then it will give the size, minimum size, maximum size. Okay, that size you defined. Okay, then automatically mesh, you can go to update option, automatically the mesh is created. Okay, or you can go to the simply mesh option, generate mesh. You can go to the generate mesh, automatically the mesh is generated. See, they mentioned. Okay, so instead of taking the video, okay, this one is, I think you may able to understand easily. So you can select the face, then you can apply, automatically the meshing is created. Then you have to go to the named section. Okay, after creating the machine, you have to select the front edge, that is the inlet portion. Lines, that line you can select. Okay, so in the top, this below the file edit view, you have the point, line, surface options are there. No, so you have to select the that is a named selection, right inside name selection. Then you can go to then you pick the left hand side, line, the edges you can select and give the name inlet, and this right hand side line you can select, it is the outlet. Okay, so after this you can go to mesh update. Automatically the mesh is updated. Then you have to go to the setup. Okay, Fluent setup, you can go. There is a 2D flow or 3D flow is coming. You can go to the option double precision for giving more accurate results. Okay, and serial or parallel mode for processing, you can go for say any one mode you can go, but okay, so serially you can do it. Is a very simple problem, you can go serially. Parallel also you can try, it is the only mode of solving. Then again the fluid setup, if you press go to the display command, the mesh is displayed. Then you can choose the solver type, that is a pressure based solver or density based solver. So normally pressure based, density based solver, density variation is coming. If it is a compressor flow, density variation is coming, so you can go to pressure based method for solving the problem. So this is actually a pressure based absolute velocity. Okay, we are giving the velocity, absolute velocity. Then steady state, the mode is steady state, not transient. Transient means with respect to time. Then 2D space, you can go to the option planar, 2D planar. Axisymmetric case for any, for example flow in a axisymmetric pipe or spherical tank, only one half portion if you draw, no, then you can go to the axisymmetric option, but it is a planar, 2D plane. Okay, plane stress, plane strain, we discussed in the subject. So the same option, same thing, instead of FEM now you have a planar. So 2D planar you can select. Then you can go to the option viscous laminar flow. It is not multi-phase, so you can go to viscous laminar flow, and laminar flow you can on. Then you can see the various method we have discussed in the unit 5 turbulence modeling method. Okay, all K epsilon, K omega, Spalart Almirez, transient K epsilon omega, transient S60 model, Reynolds stress model, all the models are available. Eddy simulator also available. So for simple problem you can go to this is a laminar flow model, you can choose the laminar flow. Then the next option automatically come in the setup materials. So the materials, if you have to select air is already, the medium is available, or if you want to go to any other fluid medium, you can give the value of density and viscosity. If you select the air means automatically it comes. You have to select the unit, density kg per meter cube, viscosity kg per meter second. So because you are drawing everything we have given in the meter scale. Okay. So then next you can go to the boundary condition. If you go to boundary condition, there is the inlet is there, outlet is there. So select the inlet and give the velocity 0.1 meter per second. Okay. Then you can go to the outlet portion and select the pressure, that is the stationary valve. So outlet is, the pressure is 0. No slip condition, the boundary condition you can give. Then solution method, see, simple algorithm is there, simple C is there, PASO algorithm is there. Okay, whichever you want we can select. Okay, then gradient based methods are there. Okay, pressure based methods are there. Okay, momentum based method, first order upwind, second order upwind. So whatever the subject we studied, we can go to simple and gradient based method and standard. So all the methods you can give the answer, but sometimes the method is giving it can able to solve the flow very accurately. And turbulence modeling, this is actually laminar flow we are doing. If you are having turbulence modeling, you can try with a different method, simple CPASO and other standard method, second order method. Okay, if you see that, then there will be little bit variations coming. Then you have to match with your exact answer. Then you can able to find out the answer. Pressure velocity. Then you go to solution monitoring. So while solving the problem, what type of solution it is going to, you have to monitor. So you can go to residual plot. We are going to see the continuity equations. Okay, continuity. Velocity only we are going to monitor. Okay, so that is the continuity. X velocity, Y velocity only we are going to monitor. Then we can go to solution initialization process. Just give the inlet boundary condition that the pressure is 0, couch pressure is 0. Then you can run the calculations for 1000 iterations. You can set and you can run the calculations. So when you are setting more iteration, no, the solutions converge very fast. If you are setting very less iteration, no, the solution may not be converged. See, if you are setting 10 iteration, the solution is not converged. Velocity and both velocity. Okay. So velocity and pressure also there. Okay. So after solving this, we can just go to the post processor just to see the result. Velocity contours. Okay, you can able to know what is the velocity we apply. No, same velocity is coming in the outside. Okay, and in the boundary layer, laminar flow, the boundary layer is there. So the boundary layer will be disturb the flow. So in the middle you have a 0.1 meter per second is there. Then the other side you may have a less velocities.